Okay, good. This is day, I can't remember what day it is, 19 or 20 or something. And, um, hmm, this is interesting, because I'm not logged in. Why am I not logged in? Okay, now I'm logged in. Okay, so this is day 20. Um, and let me make sure my live streaming is working. And I hope it's better than day 19. If it's another day like day 19, I'm gonna, cry. Um, so, uh, yeah. All right, day 20, a regular map. Good, so so let me make a file. As always, day 20 regular map. This is another one of those pathfinding algorithms. I'm also going to be pissed. What you're learning about instruction pointers, the else made considerable progress. So a North Pole base, blah, blah, blah. The area you're in is made entirely of rooms and doors. The rooms range in a grid, and rooms only connect to eastern rooms when doors present. For example, drawing rooms as dot, walls as pound, doors as pipe or dash. Your current position is X, and where north is up. The area might look like this. You get the attention of a passing instruction help and ask for a map. I don't have time to draw a map of this place. It's huge. Instead, I give you directions to every room in the facility. He writes down some directions on a piece of parchment and runs off. In the example above, your instructions might have been west, north, east. A regular expression or regex. The regex matches routes like west, north, east that will take you from your current room through various doors in the facility. In aggregate, the routes will take you through every door in the facility at least once. Mapping out all these routes will let you build a proper map and find your way around. Caret and dollars are at the beginning and end of your regex. It just means the regex doesn't match anything outside the routes it describes. Specifically, caret matches the start, dollars matches the end. These characters will not appear much to the regex. So the regex matches very sequence of the characters north, south, east, west. In the example above, west, north, east matches only one route. Continue to move west, then north, and east. Sequences of letters like this always match that exact route in the same order. Sometimes the route can branch. A branch is given by a list of options separated by pipes and wrapped in parentheses. So, starts with north, east, or west, contains a branch. After going north, you must choose to go either east or west before finishing your route. Going north again by tracing out the possible routes and branching. You determine where the doors are and again where the rooms are. For example, consider this one. This regex begins ENWW, which means for your current position, all routes must begin by moving east, north, and then west 3 times. East, north, west, 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 in that order. After that, there's a branch. Before you consider the branch, this is what you know about the map so far, with doors you aren't sure about marked with a question mark. So after this point, there is this thing. This gives you exactly 2 options, NEEE and SSEEEN. By following NEE, the map now looks like this. Now only SSEEEN remains because it is the same print size group as NEE. It starts from the same room that NEE started in. It states that starting from that point, there's used south, west, and east. Those rest of the doors. Once you followed all possible routes, you know the remaining unknown parts are all walls, producing a finished map of the facility. Sometimes a list of options can have an empty option, like this, this, or this. This means that routes at this point could effectively skip the options in parentheses and move on immediately. For example, consider this regex and the corresponding map. Start, go east, north, northwest, southwest, west, news, or nothing. That. This regex has one main route, which at 3 locations can optionally include additional detours and be valid. Regardless of what option is taken, the route continues from the position it is left at after calculating the steps. So, for example, this regex matches all of the following routes and more that aren't listed here. Yep, by following the various routes full map, you get a sense that you'd like to determine which room is furthest from you. Specifically, you'd like to find the room for which the shortest path to that room would require passing through the most doors. In the first example, this would be the northeast corner 3 doors away. In the second example, this would be the southeast corner 10 doors away. In the third example, this would be the northeast corner 18 doors away. Find the room for which the shortest path to that room would require passing through the most doors. What is the largest number of doors you would need to okay, so despite this being a grid, I would like to think of it as a graph problem because I think the grid is slightly misleading. So I get a regex, and I think this is actually kind of a cool problem. I say, about to hate it, but so anyway, to start with, let's look at our puzzle input, and that'll give us a sense of, are you fucking kidding me? Okay, good. So let us parse this regex. And so so we need to parse a regex, and a regex is always going to be so let's think about this, and so let me just start with this and say raw equals that, and so a regex is either going to be let's just say a regex is a list of what do we want to call these? Regular expression matches routes. Is a list of chunks, and a chunk is either so from enum import enum, or I'm gonna regret using enums as I always do, but I'll do it anyway. And then from typing import list, so class direction enum.enum, and that will be north 0, east 1, south 2, west, and I think it's actually this, maybe, I forget. Anyway, I think this is the right syntax, and so a chunk is going to be so let's say a path is a list of direction, and a chunk is either going to be so there it's a list of direction, so it can be a path, or it can be a list. These recursive types, Python's not going to let me do recursive types, so that's fine. So we're not going to use types for this. So what I want to do is I want to turn raw into something that looks like E N W W W, and then this list, and this list is going to be so the first thing is going to be N E E E, or it's going to be S S E, and maybe I'll make this a tuple, where a tuple means that I have a choice, and that's fine. I'll try doing this SSE, and then with the last one can be either EE, or it can be N, and then SSEEN. So that's right, and then that. So I want to parse it and do something that looks like this, because then what I can do is I can say, if while I've got things, go. Otherwise, if I end up with a tuple, so this is like using types in like a really kind of cheap way. Message retracted, message retracted. All right, someone's trying to troll me again, I guess. So to start with, let's write a function that can parse one of these regexes, and I'll call it a list. And so let's think about how to do this. Let's say path equals this, and I'm not even going to worry about the beginning and the end, so I'm just going to say regex equals regex 1 to -1. So that's going to get rid of the thing and the dollars because we know that's there. And I think in all the examples, it's there, so I'm just going to ignore it. So we don't need to know it. So then that will be this thing. And so what I want to do is I want to say, and you know what, I'm not going to use this either because I'm using strings. And so I'll call this master path, and I'll say this is the exact same parsing problem that I really struggled with last time. And so what do I want to do? So let me, I'm going to need like two functions that call each other. So what I want to do is I equals 0 while I is less than len of regex, and like I said, I'm going to screw this up. If regex I equals that, and then otherwise I'm going to say, so path equals this, otherwise path dot append regex I, and I plus equals 1. Otherwise, what I want to do is I want to say choices I equals, let's say, parse choices regex I haven't written that function yet. So I'm going to write, again, a function that will like find these parens, and then what I'm going to do is I'm going to say path dot append choices, and that's it. So I should be so now I need to write this parse choices, parse choices regex, which is a string, and I, which is an int, and it is going to return a tuple of a list and an int. So that's fine. I need a tuple, and we'll see how this goes. So if we're here, that means that regex I is an open paren. So we need to go until the last closed paren. So what I want to do is I want to say num parens equals 1, and while num parens is bigger than 0, let's say I plus equals 1 while num parens equals 0. So now, let's say I've gone in here. Oh, Jesus. Or yes. So as always, this is what happens when you don't do Haskell for like a million years. Is you get really bad at parsing things. So what I need to do is I need to say go all the way to the end, and now basically here are my choices. So go, up to this thing is good. And so okay. So actually I don't need to do num parens. What I need to do is the following. So let's say choices equals this, and current choice is also this. So we skip one and we say while regex I is not the closed paren, I want to do the following. If regex I is north, south, east, or west, then the current choice, we would just want to append it. Append regex I and I plus equals 1. Okay, so that's one option. If regex I is this pipe character, so I get up here, then what I want to do is I want to say, and I probably don't need to, so I see a pipe, so and then I need to say choices dot append current choice. So that means we end our current choice, and then current choice is a new empty list, and so this should be an elif, and then the last thing is current choice equals that, and again I plus equals 1 I need to do, right? And then otherwise, if regex I is an open paren, then what I want to do is I want to say I've gotten in here now, so I want to append to my choices a recursive call. So what I want to say is sub choices I equals parse choices regex I. So I want to make a recursive call to parse choices, and then current choice dot append sub choices, which I think is how I imagined it, right? So yeah, like so I have S, S, E, and then this thing. So sub choices. And now once I break out of here, I will have, so if I, where's raw? So when I get to this ending parentheses, I will have built up, like here I've built up n, and here I've built up the second thing. So I need to add that to choices dot append current choice, and then I said I want to return tuple of choices. So let's see if this works. It probably doesn't, but is this really day 20? Okay, good. So parse raw string indices must be integers. Okay, that's interesting. So that's line 16. Return tuple choices and I plus 1. Okay, so once I get past the closing parentheses, I want to go on to the next spot and not worry about it. So let's do that. And return path. As always, I forget to return things for my functions. So this is saying, so let's see if this does what I wanted it to do. On its face, it looks reasonable. So I said I want it to look like this, and it actually looks like east, north, northwest. Now I go into this thing. This is northeast, east, then also south, southeast, and then east, east, north. Okay, so that seems to have done what I wanted, which is good. So hooray for me! I learned my lesson from that first parsing one where I did terribly, and now I'm doing less terribly. So I feel like I've bitten off an important piece of the puzzle. So now what I need to do is I need to say def explore path. So let's take a path, which is a list, and that's not quite right. But I'm gonna fudge with the typing a little bit. And so what do I want to do? I want to return a map. And so what is a map? Class map named tuple. So it is going to return so basically I'm going to start somewhere and go to a bunch of places, right? So I'm going to do a couple of things. One is I'm going to give each of these a bunch of coordinates that are relative to where I started. And the second is I'm going to keep track, and I'll call those nodes. And then I'm going to keep track of the edges as well. So a map will be, and so what did we call these? We call these a room. So, a room is just a tuple of int. A map is going to have rooms, which is a list of room, and it is going to have doors. And so a door is a tuple from room to room, let's say. And so a list of door. So I'm going to explore this path and return a list. And so again, I'm going to need a queue to explore because I want to branch out. So from collections, import the good ye old double-ended queue. And so let's say, so let me think about this for a minute. So I want to go all these things, and now once I get to this thing, I basically want to stick each of these on my queue. So let me see what the input looks like, because this, part of me wants to just multiply it all out, but part of me does not. And a queue actually seems wrong now. I think what I really want is a stack. So, well, it doesn't really matter. So here's what we'll say is we'll say, a route is a location and a remaining path. So what I want to do is I want to say, so I think my queue will be okay actually. Q, I'll just call it Q equals, my double-ended queue, and it's going to take, I said, a location, which is 0, 0, and a remaining path, which is the initial path, okay? And what I want to do is I want to say, and let's just say, and I'll make this a set too, because rooms is a set, and doors is a set. And that's just because I'm going to encounter the same ones multiple times, and I don't want to have to worry about duplicates. So this will make my life easier. Class route is a named tuple as well, and let's say a route is a location, which is a route has a room, which is a room, and a path, which is a list. Again, I'm cheating. And so now I just think this will be easier to read if I say it's a route starting at 0, 0, and at the path. So that's my deck. And so while there are things, I want to say route equals q dot pop left, and can you decompose name tuples like this? I actually don't know that. Typing import named tuple. That's an interesting question. Class A named tuple I and j string. A equals A of 5 this, and can I do xy equals A? I can, because it's a named tuple. Okay, that's fantastic. So let's say room path equals q pop left, and I'm renaming path. I think that'll be okay. And so what do I want to do? So I pop off the path, and it's going to be a list of things. And let's say rest of path equals path 1, and next step equals path 0. And so now what I want to do is, I might hit the wrong edge case there. If is instance next step tuple, so that means it's one of my choices. And then otherwise, if it's not a tuple, then necessarily it's going to be one of the directions. So let's say if next step equals north, then what do I want to do? I want to say, and not only that, I'm actually going to decompose the room as well. So if next step equals north, let's say room equals, I don't know how I want to call those directions, x, y plus 1, and q dot append route. I'll just even do it like this. Route xy plus 1, rest of path. So I think that's right. And then, if it's south, I want to append a y minus 1. And I should be appending doors too, so I'll do that in a second. And I should be tracking rooms. Okay, let me do this. Let's say room path equals this, and let's say xy equals room. Next step, let's say next room equals xy plus 1. If next step equals south, next room equals xy minus 1. If next step equals east, next room equals x plus 1 y, and elif next step equals west, next room equals x x minus 1 y. Okay, and then what I'll do, else raise value error bad next step make it an F string. Okay, and so now what I want to do here, and so I'll have to break out of let me, and I'll do a continue here, so make sure that it continue, and then I break out of it, and so now what I want to do is I want to say in rooms equals set, and I'll start with 0, 0 as a known room because it's a known room. And now I'll say rooms.add next room, doors.add, and for now I'm just going to add doors in both directions because I don't care that much, and it'll probably make my life easier. So, you know, if I have a door, it's going to do that. And then what I want to do is I want to append to the queue the route, and I'm sort of regretting making this route a name tuple, next room, rest of path. Okay, so that's fine. And now what I need to do is go to this next step that's a tuple, and that's all right too because each of those is basically a path, is a choice, right? So for choice in tuple, and I know that choice is a list. So we want to say q.append the route that starts in this room, and its path is choice plus rest of path. So basically what that means is that when I get here and it says this is one path and this is one path, and I'm at some room here, say I've gone over here, then that says I have one thing which is, and here there's no rest of path after this, but let's say there was, then starting here do this, and then also starting here do this. So I think that's okay. I don't think it really matters whether I do a queue or not. And so what I want to do is say, I have this parse. So again, let me do path equals parse raw. And let me say map equals explore path path. So let me run this and see what goes wrong, because something will go wrong. Name set is not defined. That's pretty easy to fix. Type object is not literable for choice in tuple because for choice in next step. Okay, so let's do this now. List index out of range because okay, I said this was going to bite me, and now I've added a room when it's already known. So so let me just add this and say if not path. So this is an empty path. Then just continue. So that's fine. I thought that was going to bite me, and it did. And so now if and let me guess. I need to like tape a sign to my wall that basically says, and actually, if I ran MyPy, it would tell me that I forgot to do a return statement, and so I use these type hints, but I'm not doing MyPy, and so that's sorry. Okay, I'm going to use cursor to point. So explore map rooms doors. Okay, so let's try this one more time, and then if I look at the map, it's saying that my rooms are. Gosh. this is hard to make sense of, but let me consider this regex, and so this is my map, and so and where did I start? I started. What is X where I started? Yeah, so X is where I started. So let's go over here and put this in, and hopefully it's a comment. So this is 0, 0. So I have 0, 0, 0, 1, 1, 2. How do I have 1? So 0 over 1 up. Okay. 1 over 2 up. Minus 1 over 1 up. Oh, right. Sorry. So 0 over 1 up. 1 over 2 up. Minus 1 over 1 up. 0 over 0 up, obviously. Minus 2 over 1 up. Minus 2 over 0 up. Minus 1 over 0 up. 0 over 2 up. Minus 1 over minus 1 up. Minus 2 over 2 up. Minus 1 over 2 up. Minus 2 over minus 1 down. 0 minus 1. Okay. So these look like the right coordinates. And now, are there the right doors? So one door goes minus 2, minus 1 to minus 2, 0. Okay. So I'm just going to put a Y over that. Minus 1, minus 1 to minus 1, minus 1 to minus 1, minus 1 to minus 1, 0. So that's this guy. So I'll put a yes here too. Minus 2, 2, minus 2, 2 to minus 1, 2, which is this guy. So he's good. Minus 1, 2 to minus 2 to minus 2 1 to minus 1 1. So that's right. Actually, let me just do this backwards. So this is saying that from minus 1 2 we should have to 0 2. So minus 1 2 to 0 2. Yep. So 0 2 we should go to 1 2. Yep, we have that as well. From minus 2 2 we should go to minus 2 1. So if I see minus 2 2 minus 2 1. Anyway, it looks like this is doing the right thing. So I have some faith in it. And so now we've got and let's make sure that the empty options work too. So let's just say raw2 is this, and path2 equals, and let's just make sure this works. Raw2 and map2 equals explore path 2. So let's see if this runs into an error or not. So path 2 has some empty lists in it, which is great because an empty list should work. And then map 2 seems to be doing good looking things. And let's just make sure that if I get an empty list, so I get a path, I stick it there. If it's not a path, then I just continue. So that's fine. So I think this is pretty reasonable. And now we get to the actual rest of the problem, which is what is the largest number of doors? That is, find the room for which the shortest path from your starting location to that room would require passing through the most doors. What is the fewest doors you can pass through to reach it? So basically, we want to find the shortest path from the start to every location, and we want to find the longest, shortest path. Okay? And so what we want to do is, let's say, def all shortest paths, and we're going to take in a map. Map already means something in Python, so I don't really want to use that as a name. So call it my map, which is a map, and it is going to return a dict from rooms to ints. So for each room, it's going to tell me how long is the shortest path. So I'll get dict here, and now this is like a very standard breadth first search, which I think I can do. So back pointers is this, and actually I'll say 0, 0 to none. And actually, I don't even need that. I just need shortest paths. And in part 2, they're going to make me regret this. But I'm just going to keep track of what is the shortest path to each one. And as soon as I find one, I know what it is. And let me say, I'm just going to pre-compute my neighbors. So neighbors will be a dict from room to list of rooms. And that way I just know who all my neighbors are. And that's going to be default dict list. Did I import default dict? I did not. So let us do default dict. And so this is just because it'll be a pain in the ass. Like I have my doors as a list, and that's a painful way to like look for doors. So for from room to room in my map.doors, and you know we have both directions, so that's fine. All I want to do is say neighbors from room dot append to room. Okay, and so once I do that, then that says basically that if you go back here and look at these things, I'll say you know, here's a door between these two. So for this guy, I'm going to append this as one of his neighbors, and then I have them in both directions, so I'll just get that both directions for free. So I have all my neighbors. That's good. And then my shortest path is that. And then again, I have a queue, which is just going to be a double-ended queue that starts with 0, 0, because that's where I start at. And again, I'm feeling pretty good about my decision to represent this as an actual graph with like nodes and edges rather than as their little grid. I think representing it as the grid they drew would be a real pain in the ass. And so again, while there's something on the queue, you know, room equals queue pop left. If for next room and in neighbor's room, if neighbor is in shortest paths, so that means we've already explored to here. Then we can just continue. So we don't like if I'm seeing a room that I've already seen, like he's already handled, so I don't need to do anything. And otherwise, I haven't. So what I can say is that the shortest paths to the neighbor equals shortest paths to the room plus 1. So, you know, I know I've been to room before, so I know how long it took me to get there. I had one, that's how long it took me to get there. And then I want to append the neighbor to the queue because this is the first time I've seen him. So I would like to explore his neighbors in case we haven't seen them yet. And then just return shortest paths. So let's say ASP equals all shortest paths for map, and ASP 2 equals all shortest paths for map 2. And let us run this and see what goes wrong. Neighbor is not defined for, I'll call it neighbor in neighbor's room if neighbor and shortest path. Blah, blah, blah. Okay, so let's try it again. Okay, so ASP, all shortest paths, is saying that if I want to get to 1 minus 1, that's 10 away. So that was this one. So 1 over minus 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that seems right. And ASP2 goes all the way up to 18, which is the right answer. And so here are a few more examples. So let me just def end to end takes a regex, which is a string, and returns an int. So what we want to do is we want to say, how did I call all of this? If I parse it, it's a path. So path equals parse regex, and my map equals, is that right? Equals explore path path, and then ASP equals all shortest paths from my map, and then I want to return the max of ASP.values. So now to make this really easy, we'll assert that end to end of raw equals, and I said 10, assert that end to end of raw 2 is 18, and then they gave me 2 more examples. So this says 23. Assert end to end of this equals 23, and then finally I have this guy, which is 31. So hopefully these work, because otherwise I'm going to have to debug why they don't, and that'll be a real pain in my ass. 31. So let us run this. And all my tests pass. So that's pretty good and exciting. So now let me get my puzzle input, and this is a big honkin' mess of regex. So let us go to, and I know they're gonna fuck me in part 2, but that's fine. So it's day20.text. So now let's say with open data day20.text as f raw equals f.read print end to end raw. Okay, so let's run this. Bad next step dollars. Okay, so why is that? That is because there's extra stuff at the end, and I need to strip it, is my guess. And so there was extra white space at the end, and so when I did the thing to remove the caret and the dollars, it didn't actually remove them, so it was removing white space instead. So with a strip, let's try it again. And is this another thing where it's just going to take too long? Maybe. And I don't have any way of tracking my progress, which is bad. So print path, print map, print ASP. So which of these is the slow part? It's probably the the finding the map. So let's run this again and say, so there we parsed it, so that's fine. And so we parsed it pretty good. And now exploring all these things, we're having some kind of combinatorial explosion where I do, I do all of this, and now I get here, and I can either do that one or that one, so that's fine. And then I can do this, and so, one thing we can do, because you know that this explore path was going to be the slowest part. So let's import TQDM, and this doesn't really make sense with TQDM. But what I would like to do is just understand like how big the queue is. I don't need TQDM. I'll just print q comma len q, and we'll see how that goes. So let me try running this again. And this q is just so that's not really helping me understand how it's doing. So let me do one more thing. Room path equals print q, len q, and len path. So that will help me understand how much of the path is left as well. So this thing could run like forever, basically, which is unfortunate. So while it's running, let's think about what optimizations we could do in order like one thing we could do is we could the problem is that these long stretches aren't really bad. What's bad is all these splitting into choices. So you get these huge combinatorial explosions of each time you get like a little this or this, you're basically it's not so bad there, but like let me go to like the early ones, that when I get a nested one, suddenly there's like a bunch of things that I need to explore. So, and my queue is getting really big. 260,000, 265,000. So like I can let it run to see if it ever finishes. But I would like to figure out a way to do this faster. So one thing I could do, or I could try to do, is try and track the shortest path while I'm parsing the regex, right? So as I go here, and then it doesn't feel like that helps me a ton, but as I'm doing this, I'm building up, as I go here, I'm building up a list of rooms, and I don't even need to track the doors per se. All I really need to do is track, have I been here before, and is this the shortest path to get here? And then the question is, what happens when I split this? When I split it, I just need to explore that from here, and also don't explore that from here. Right. So every time I reach this, I'm basically doubling the rest of the work I have to do, right? Unless west, west, east, east, south, east, west, north. So west, south, north, east, or so maybe here's an optimization, which is the following. Because this thing, although it seems to be coming down now, so no, it's going. Let's see what happens. It looks like it might be finishing, or it might be like getting a lot worse. If it's getting a lot worse, I have an idea, but seems to be coming down. But what's going to happen is in part 2, they're going to do something that makes this slow thing even unbearable. Like here, it looks like it's finishing, but I think there's a way to make that idea work. And if this doesn't work out for us, I'll try it. But it seems like it's. I feel like I'm watching a machine learning model train. So anyway, the idea is that we build up, instead of going through like 3 passes, we do like 1 pass, and now this is going back up again. So let me try coding that up. So now, so my parsing code is fine, and so let me do the following: def all shortest paths to, and it will take a path, and it's going to return a dict from room to int. Okay, so hunch where they're going halfway through the problem. Does intuition guide you on what you'll do? So a couple of things. One, I have done enough of these that I like to guess at what part 2 will be, and hunch of where they're going. My path is never clear, so this thing's still going. So let me, while that's running, maybe it'll finish. It's not, but here's my idea. So so this is going to be, I'll just copy this Explorer path code because I think it's interesting. So what I want to do is I want to say shortest paths equals 0, 0 is 0. Okay, and that's all I need. And again, Q is a double-ended Q of root 0, 0 and a path. And so now what do I want to do? And let me just check on this guy. He's still running forever. So if I've got an empty path, I can continue x what. And so now what so now what I want to do, so I'm just going to change this slightly and say if next room not in shortest paths next room equals shortest paths room so let me go here and say room path and let's say shortest to here equals shortest paths room. And so if next room is not in shortest paths or shortest paths next room not in shortest paths or shortest paths next room is bigger than shortest to here plus 1, shortest paths next room equals so basically if I haven't been to the next room or if I have been there but this is a quicker way to get there, then I will append this. And let's go check on this guy, and he's still chugging along forever. And so that's fine. And you know, return shortest paths. And now what I want to do is I want to be smarter about how I handle these tuples, right? Because if you look at some of these, right, southwest, okay, so that's a real tuple. Here I have east, south, so that's, yeah, so that's not great. Here I have west, 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 or east, so that's not great either. Like somehow I want to collapse out some of these tuples. So I was thinking that was a good idea, but now that I'm looking at it, I'm not seeing that many where it will help. So like this northwest, east, south, or nothing. Northwest, east, south will get you back to where you started. So that's nothing. But here's one that's north or south. So that's not really going to help unless I can get like much smarter about how I do this. So like west, west, east, east, south. So these two, sorry, this west, west, southeast, west, north. So west, west, east, east will cancel out, and then so this will get you back where you started as well. So like at the end of both of these, you're at the same place, and then same with this one, and so like a minor optimization is just to remove every one of those, right? Because if you think about it, this is basically doubling the work I have to do. This is basically doubling the work I have to do. And so, you know, one tiny optimization is to say nothing further nested. So if so this is a really simple one. So what do paths look like? Paths look like this, right? So if I have a tuple and every tuple is has no tuples in it, So how do I want to say that? So if not any step, if not any is instance step tuple for subpath in next step for step in subpath. So then what I want to do is I want to say so like that's kind of like this thing here. So I get to these choices. This guy has no tuples in it. This guy has no tuples in it. And okay, so now I'm starting to get an idea now. Is that I want to, and so let me do one more thing, which is offset from a simple path, which is a list of strings, and it's going to return, it's not really a room, it's a tuple int, and this guy's still running. And so what I can do is I can say x, y equals 0, 0 for step in simple path. If step equals north, y plus equals 1. Otherwise, if step equals south, y minus equals 1. Elif step equals east, x plus equals 1. Elif step equals west, x minus equals 1. Else raise value error bad step. Step. And then once I do that, I can just return xy, and that tells me if I have a path, where do I end up from here. And actually, let me do this actually. Final room, room, and simple path. And so now I'll do xy equals room and return xy. So that will be a little bit better. And then from collections, I also want to report counter. So in this case, where I have nothing further nested, I want to say destinations equals, I wonder if I can do this in the nested case too. It's possible I can. So that's actually even better. So let me be real smart about this. And let me say I'm going to add something to my routes and call it basically a time step, which is an int, and I'll set it to -1 so that I don't have to fix my old code. So here's what I want to do. So route 0, 0 path and then time step 0. And what I'm going to track is locations by time step, which is going to be a dict from an int to a set of rooms. And so this is going to be, and actually it's going to be 0, and it's just going to be 0, 0, so that's fine. So basically what I'm going to do is, and let's see how I'm going to make this work, because I am going to make this work. Q.append room choice. So room path equals Q pop left. Sorry, room path time step. Room choice plus rest of path, comma, time step plus 1. And then otherwise, I'm also going to do time step plus 1. And now what I want to do is basically the following. If room in locations by time step dot get time step empty set. Okay, so if I visited this room before at this exact time step, no, I don't think I want to do. I don't think I'm doing my time steps quite right. Here's what I want to do. Time step. Time step equals 0. Let's do time step plus equals 1. And so next, yeah, the thing's never going to finish. Okay, so next time step plus equals 1. So I want to, basically the idea is whenever I put something on a queue, so time step is the wrong thing to call it for the following reason. Let's say I split, and let's say I have something that looks like east or west, and then north or south. Okay, so in some sense, this is time step 0, and this is time step 1. But I don't want to think of them that way because basically, after east is one thing, after west is another thing, which is fine, and then after north is one thing. After south. So basically, I don't want north after east to be considered the same as north after west. So, so I think so. So I don't even want to call it time step. I want to call it something else. So let me call it. What would I call it? I would just call it sequence ID. It's too much like time step. I'll just call it time step. But remember, it's not time step. It's something that's not a time step. Next time step plus equals 1. So I do that. So if room in locations by time step get time step set, then I've seen this, like I've already been here before at this time step. So I just want to continue and just short circuit, you know, and so on and so forth. If not path, since it's q dot append, and let's just say next time step, rather than time step plus 1, next time step, and again next time step. So yeah, so let's just stop that guy. So let's see if this even works. So end to end 2, and now all we want to do is say path equals parse regex, ASP equals all shortest paths to path, and then return max of that. And so now let's see if these unit tests pass. And let me just comment this out. Probably they won't, because probably I screwed something up. Too many values to unpack. Okay, well, let me even comment out like most of these. So too many values to unpack. Map equals explore path. So I don't even want these things anymore. Don't want that. Don't want that. Don't want that. Don't want that. So run that. Assert end-to-end raw. So I don't want these either, because I've basically abandoned that approach. So now let's try it again. Name path is not defined. How is name path not defined? Because it's not a path, it's just a list. Okay, so let's run it, and good. So that's getting closer now. Print path, print ASP. So let's figure out what I screwed up with that. So that's my path, and the ASP is nothing, because did I never add to it? So print room path time step next time step. So let's do that and check it out. Room path time step next time step. If room in locations because I did something stupid. So I'm not going to stick him in there. So let's try this again. And my assertion passed. So that's actually pretty good. I have too many prints here, but let's run these. And so those, that's good too. Let me take out some of these print statements, and I still have too many print statements. So where are all my print statements? Here they are. Okay, good. So now that I've done that nasty optimization, which seems to work with all my test cases, let's try this. And so let me see if this is biting. So print skipping. So let me run this. And it's not working. And so why is it not working? So let me add a test to figure out why it's not working. And so let's say raw 3 equals that. And let's say east and then north, south, or nowhere, and then east. And so print end-to-end raw 3. And I'm actually just going to comment these out for now. So if I run this, too many values to unpack because I forgot to do $1. Still too many values to because I want to do end-to-end 2. So let's run it, and that's saying 2. But in particular, let us print Q, print locations by time step, and so it's not skipping. So let's run this. So here I have this guy. I go to 1, 0, and now my next path is a split. So now I stick both of these on, and east equals 2. And now I pull him off. And so the problem is that I'm actually appending at the ends. So that's the issue. So let me think about how to solve that. It's not that simple. So let's think about this. The problem is that I get to here where I say my path has 2 steps, and now what I've done is I've split this out, and so really what I want to do is north, south, east. So I get so I pop this guy off and I follow him all the way to the end. Actually, no, I take him 1 step and then he goes here, and then I take him another step, and so I do that guy. Then I've got, 1, 1 southeast, so I do him, and now I've got 2, 0, 1, 0. So east will take me to 1, 0. North will take me to 1, 1. And then south will take me back to 1, 0. And then east will take me to 2, 0. So when do I get to room 1, 0? I get there here. And then I do, north, south, east, and then east from there. So I do the north, and then okay, so gosh, so I'm doing something really stupid. I'm an idiot. Okay, so so let me go back to my first version. I did something really dumb. As always, now, God, pretty stupid. So let me comment all this shit out. Okay, so and let me go back to my first approach, which I think was okay. It had a really dumb mistake in it. I think, and what that is the following. When I explore this path, what I want to do is the following. So for next step, so let me do this. For I, next step in enumerate path. And so I don't need to do this. What I need to do is, so I'm just going to go over this path. So if is instance next step tuple, then what I need to do is I need to say rest of path equals path I plus 1, and then for choice next step q append route room choice plus rest of path. So that's fine, and continue. Otherwise, and then rooms add. Okay, so basically the problem was that well, one problem was that when I had this north, south, east, instead of just going to the end, I was pulling off north, sticking south and east back in the end, pulling off south, sticking south and east back at the end. So that was already causing me like a ton of grief. So let me make that change and see if that so uncomment this, uncomment this, uncomment this, uncomment this, uncomment this, and now let's run it like that. Too many values to unpack, and room path. I don't need this time step, but it's there, so I'll just do it like this. Local variable rest of path done by assignment. So now I don't need to do this. I only needed to do that when I had okay, so and now it's broken, but let's figure out why it's broken. So let's do raw looks like this, path looks like this, ASP looks like this basically, which is not right. And so what does map look like? So I don't have enough rooms, and I don't have enough doors. So let's go back to how we're generating the map. So print, you know, from room went next step to next room. And so let us do this and run it. And this is from 0, 0. So why is that? Because I need to say room equals next room. So let me try that. And try this. So what's ASP here? It's still the same bad stuff. So what's map? So like these are very wrong. So let's figure out why they're wrong. So Q, len Q. So rather than that, I'm just going to do QQ path. And let me try running it now. And this is like craziness. So there's nothing in my queue. I have a path. There's nothing in my queue, and I have. Am I sticking too much stuff on the queue? I don't think I am. Times it. Shit, have I been doing this for an hour and a half? God damn it. Y equals room. And this needs to be inside here. And now did I pass my assertion? I think I did. So this is too many print statements. Okay, so they all passed. So now let me take out the print statements. Where are the print statements? Print Q, and just I'll leave that there. And so let's run this. That's fine. And now, where where's the other thing that I needed? Let me stick that up here and see if it runs. It's probably not going to run, and then I'm probably going to quit because I'm tired of this. And it is still going way up high, just as bad as it did before. So that's not good. Actually, no, it's not as bad as it was before, but it's still bad. All right, so now I need to go back and try and do this thing again, and fix it in the exact same way. So let's comment this out. So again, this thing mostly works, and I just need to basically copy out the inside of this loop. So I have this if not path continue, and then I have this whole thing here. So let me go down to this part. So here I'm skipping some stuff, and if not path continue. So now let's see what needs to change about this. XY equals room if it's a rest of path for choice q dot append room choice rest of path, and again I want to call that next time step continue. Otherwise I don't want to waste time steps, so I just want to chug along here, and now I just need this logic. So if next room is not in shortest paths, or shortest path next room is bigger than shortest to here plus 1, then shortest path next room equals shortest to here plus 1. And then I don't need to keep track of any of this stuff. I'll just do room equals next room. And now I don't think I need any of this stuff. Return shortest paths. So now let's see if this works. Assertion error. So let me take out all of these guys and run this again, and I still am printing. Why am I printing those? I'm printing those because I did this, and I don't want to do that, and I also don't want to do any of this stuff. So okay, so end-to-end to raw. So let's do print q, and then print locations by time step, and then print shortest paths, and we'll see what goes wrong. And then I will quit and go to bed. So here's my queue, and do this. So what happens is, that's that. So I go east to 1, 0 and say I can get there in 1 step. I go to 1, 1. I can get there in 2 steps. So what? What am I printing? Print LBT, and then print SP because I'm not sure which is which. Shortest path is that. So my shortest paths are definitely wrong. My locations by time step are also definitely wrong because I'm not setting them. So if next room not in shortest paths, or shortest paths next room is bigger than shortest to here plus 1, shortest paths next room equals shortest here plus 1 room equals next room, and I need to set this variable again. So let me try this now. Raw2 is not defined, so let me do that. But it's still not skipping those things I wanted to skip because I'm never setting the LBT variable, locations by time step. And so what do I want to do? What I want to do is say and let's say xy equals room locations by time step next time step. Is that right? No. Time step add room. So now let me do this. Since by error time step. So locations by time step should be a default dict set. Okay, so that didn't work. So let's look at why this didn't go wrong. Locations by time step. At time step 0, I went to all these places. At time step 1, I went to all these places. And then my shortest paths are 1, 2, and 10. So let's go back to so I don't want all these tests. I just want the one. So here's the skipping. So what am I skipping? Print skipping a room at time step. Why? So skipping -2, 1. Skipping, where is this guy? So starting here, -2, 1 at time step 1. Somehow this logic is not right. That logic is right. And so shortest paths are there. So I want, sorry, I don't want these intermediate, where's the locations by time step? So I actually don't want to do that. I only want to do that if so let me think about this. So I have a bunch of choices, and at the end of each choice right. So what I want to do is basically say locations by time step room, no, time step, add room. So is that right? I don't think that's right either. So basically, whenever I get to how do I want to handle that? Whenever I come back, so basically whenever I get to the end of one of these routes, and I will never know I'm there because I don't have this distinction between choice and rest of path. Yeah, this isn't working, so I'm gonna give up for the evening because this is too long to be spending on this crap. All right, good night. This was not a good one. Sorry.